Hello friends, welcome to the second video on central limit theorem. In the first video, we saw about the introductory part of central limit theorem, the two different formats and how we can arrive at the formula for x bar and Sn, which is the average of the random variables and the sum of the random variables. Now we will try to apply those two theorems which we have, those two formulas which we have learned to problems. The first problem which we are going to consider is the lifetime of certain brand of electric bulb may be considered a random variable with mean 1200 hours and standard deviation of 250 hours. Find the probability that the average lifetime of 60 bulbs exceed 1250 hours using central limit theorem. So, the first keyword we are going to look into the question is we are going to apply CLT. So, in the question paper, search for the word. So, CLT is the keyword. The first thing we have been got for. The second thing which we'll have to look for is the primarily CLT deals with two types of problem. What are they? Problems on X bar and problems on Sn. We need to check what kind of problem is our problem following. So go and search for the keywords. Whether you find keywords called as average or mean, or you find keywords like sum or total. So this will help us decide the type of our CLT. Now the question asks us, find the probability that the average lifetime. So what is going to be the question about? The question is about average lifetime of 60 bulbs. So the problem deals with X bar, the average of the random variable. So we know that we are going to now stick on to the central limit theorem, which applies your quantities to average of the data, which is X bar. We can quickly recollect that the average x bar follows normal distribution with mean mu and sigma by square root of n. So what is the first thing over here standing for? This stands for mean. And what is the second thing over here standing for? It represents the standard deviation. So what are the requirements for my formula? My requirements for the formula are mu, sigma, square root of n. So the first thing is to identify the problem and fix your formula. The second step is to collect the data from the formula. Okay, so the data required are, we will go and search the question for the data. We have been said that what is going to be the mean of the data? The mean has been set as 1200 hours. So I have mean which is going to be denoted by mu to be equal to 1200. What is the second data we have been given? Standard deviation is 250 hours. So standard deviation, you will have to be very careful over here. However, your standard deviation is denoted by sigma. Okay. So don't use sigma square. Sigma square represents variance. Sigma has been given as 250. What is the third requirement? Third requirement is n. So we know that how many bulbs has been used for the data? 60 bulbs have been used for the data. Therefore, the number of bulbs n is being given as 60. So my second step is fixing up of the data. The second step is also over. What is going to be the third step? Third step is computing the value of the normal distribution as the problem goes large in number. So how to apply your values for x bar? Here your x bar is going to denote the average lifetime of how many bulbs? 60 bulbs. So this x bar follows normal distribution with mean. What is going to be the mean? Mu. What is going to be mu? It is going to be 1200 for me. And what is the second quantity? Standard deviation. What is the standard deviation? Sigma by square root of n. So what is sigma? 250 divided by square root of 60. So I have fixed the data which has been obtained in step 2 to my formula which is available in step 1. So my step 3 is x bar follows normal distribution with 1200, 250 by square root of 60. But I need to convert the problem which is going to be in x bar to a problem in z, because I know the standard normal variate z is given by x minus mu divided by sigma. So to convert any problem to normal distribution, we will be converting it to the standard normal format. How to convert this then? So I will have to make use of mu to be equal to 1200 and sigma to be equal to 250 by square root of 60. So this is going to be the concept. Now we will move on to step 4. What is our step 4? The requirement. What is the question asked? What does the question demands from us? The question demands the probability that the average lifetime is going to exceed 1250 hours. So we want the probability that average lifetime. How to denote average lifetime? By x bar, and exceed. How to denote the word exceed? By, so it is denoted as x bar. Okay, so x bar exceeds. So this is denoted by greater than. How much you want to be exceeded by? So it is greater than 1250. So the problem is to find the probability that average lifetime of your 60 bulbs exceeds greater than 1250 hours. Now how to convert it into a problem of Z? So when your x bar is greater than 1250, your Z will be greater than. So I will substitute x to be equal to 1250 minus mu to be equal to 1200 divided by sigma to be replaced with 250 divided by square root of 60. Now use your calculators and estimate what is 1250 minus 1200 divided by 250 by square root of 60. So now we have this as Z greater than 1.55. Round it off to 2 places of decimal because our normal distribution table has only 2 places of decimal. Now my target is to find this data. So one step, write the formula. Second step, write the data. Third step, fix the formula with the data. And fourth step, for the given question, convert it into Z. Now this Z has to be evaluated using your normal distribution table. So we have been seeing this normal distribution table for the second time after we have already seen it in the first unit under theoretical distribution. When we have our normal distribution, we can see Z over here, the random variable, to be varying in your first two decimal positions in the vertical way and for the third decimal position in the horizontal way. So what we want over here is going to be Z is equal to is 1.55. Okay, so we will see how to get it from over here. 1.5 over here and a 5 over here. So what is the data? 1.55 is 0.4394. So we will keep this data ready for the evaluation. Now how to go about the evaluation of the data? Now what is the requirement? I want probability of Z greater than 1.55. Diagram is necessary when it comes to normal distribution and when it comes to examination point of view. Okay, we need to keep in mind that our normal distribution curve is going to be a bell-shaped curve. So you can draw a bell-shaped curve which varies between minus infinity to plus infinity. The center line of it is given by, we consider this to be the line Z is equal to 0. Now the requirement is Z is equal to 1.55, which is positive in nature. So 0 to infinity, this is the positive portion. So let me draw a line over here and let this represents the data. Z is equal to 1.55. What is the requirement over here? Exceeds. So it is greater than. Which portion has to be shaded when you want a greater than? The required portion will be this part. This is my greater than portion. So I want this area from my normal distribution chart. But I know that the normal distribution chart always calculates the data from the center point. So I can estimate only from the center point to this line. But what I require is an beyond portion. So I can use the property that the total area of the graph from over here to here. What can you say about the total area? The total area is going to be equal to 1. And how about half of the area? The half of the area will be equal to 0.5. So I know that from here to here, what is the area? The area is 0.5. From the table, I can get the value from 0 to 1.55. So from the value 0 to 1.55, how much this got as 1.55? Go and search 1.5 and this is going to be your 5. So how much is the value? The value is 0.4394. So how to get this beyond portion? Keep in mind the shortcut formula GST. Greater means subtract. When you have greater than, you will have to subtract. So probability of Z greater than 1.55 is the total half area, which is 0.5, subtract your table value 0 less than Z 1.55. So this is 0.5 minus the 0 to 1.55. I know that it is 0.4394. So when I subtract 0.4394 from 0.5, the final answer will be 0.0606. So keep in mind, whenever you want a greater value, you have to subtract it from 0.5. Consider the table value which is being given only from the center line to any particular position. Look into the first two decimals in the vertical way and the second or the third decimal in the horizontal way. So when it is 1.55, 1.5 is looked vertically and the second decimal, which is 5, is looked upon horizontally. So if you are clear about evaluating the data from your normal distribution charts, then the problem of central limit theorem is going to be a very easy one. Thank you.